Okay, everyone, it is time for Rule 3, which is to name the compound alphabetically. This is the last of the 3 major rules you will need in order to master naming IUPAC compounds in organic chemistry. So when we get ready to finalize and write out the name of our compound, we want to keep a couple things in mind. And the biggest thing you need to remember is that substituents are going to be named first before we name any of the parent chains. And when it comes to using the dashes and the commas, because we tend to see a lot of that in naming, the rule is that there will be a dash between any number and substituent name. So, for instance, let's say that we had something like a 5-methyl, it would be 5-methyl. If we had a 2-ethyl 3-methyl, it would be 2-ethyl 3-methyl. All right, so they go anytime a substituent name begins or ends and you have a number in between, there's dashes that are associated with that. The commas you're going to use if you're listing multiple numbers of one type of substituent. All right, so when we're looking at something like that, let's say that I had 3 different methyls, right, in position 2, another one in position 2, and then one in position 4. Then what I would say is 2, 2, 4 dash trimethyl. So whenever you have multiple of the same type of substituent, you're going to use the commas to separate each of the individual substituent number values that are associated with them. And then, as we just mentioned with the trimethyl, and we'll look here in a minute on this table, you're going to use substituent prefixes as they are needed, but we do not consider the prefixes when alphabetizing. All right, so what are these prefixes? These are the ones you need to concern yourself with. If you have a similar substituent count, meaning the same substituent over and over again, if you have 2 of them, it's di. So again, we'll stick with methyl for this purpose. So you could have dimethyl. 3 of them would be trimethyl, and 4 of them would be tetramethyl. Most undergraduate textbooks, examples that professors give on tests, etc., are not going to go above 4. It's very uncommon, but if you did, you could do 5 and it would be pent and then hex, and you could keep going up. However, it's like I said, it's very, very uncommon unless you just have a professor who's unusually cruel and wants to make compounds that are excessively difficult to work with. Okay, so those are the prefixes you need to know. Now, going back to that third point up there, you do not consider the prefixes when you are alphabetizing for the name. So if I have dimethyl, it's not alphabetized by D, it is still alphabetized by M. If I had triethyl, it's not alphabetized under T, it's alphabetized under E for ethyl. Okay, so I think you get the general idea here. These prefixes, they are just telling us how many of that substituent there is, but they are not included as part of the actual substituent name. So di has nothing to do with the methyl functionality. It's just telling us how many of them there are. All right. So here are some examples. I want to walk through these. Okay, you can see the names are already placed here, but the goal that we're going to have is to see if we can walk through and make sense of the names and where they're coming from. So what I would encourage you to do right now is to pause this just for a second and see if you can figure out how each of these were named and if it makes sense. They should be pretty straightforward. And then unpause the video in a second, and when you come back, we'll walk through it together, but see if you can attempt it on your own. All right. Hopefully everybody had a chance to give this a shot. So if you were to take a look at this, the longest chain here is an octane. It's going to be the chain that's running directly across. And when we get ready to number it, the substituents are clustered more over to the right. So we would say 1, 2, 3, 4, 5, 6, 7, 8. So that's where we get the octane from. Now, once I have the parent chain determined, I need to go in and look at my substituents. I have a methyl in position 3, and I have an ethyl in position 4. And just so we're clear, if I were to name this the other way, meaning if I were to go in reverse, it would be 1, 2, 3, 4, 5 on the ethyl and 6 on the methyl. So a 3, 4 is better than a 5, 6 in terms of numbering priority. So remember, we're implementing rule 2 there, and then we're combining it with rule 3 for the alphabetizing. Okay? And then finally, also, a lot of students will make the mistake of doing this by number. So they'll say 3 comes before 4, so then they list it as 3-methyl 4-ethyl. It's a very common habit to fall into. I've taught organic chemistry for years, and occasionally I'll slip up and I have to reverse it because I'm focused on the numbers and not the alphabetizing. It is very easy to let yourself get focused and driven by the numbers instead of the alphabetizing. Okay? So remember, the numbers do not have to ascend from 3 to 4 to 5, etc. And many times you'll see it the other way around, okay? Because it's done alphabetically. Ethyl comes first, then comes the methyl. And if we come up here to the chain, the ethyl has a 4 associated with it, and the methyl has a 3 associated with it. All right? Now, this second compound here, this one's a little bit easier. The main chain is certainly going directly across, and with the chlorine stuck right in the middle, we can number either way and it's not going to matter. So we'll just go from left to right this time and do 1, 2, 3, 4, 5. Right? So this one's a bit more straightforward than the one we were working with before. And you get 3-chloropentane. Right? So pentane would be the main carbon parent chain, and then in position 3 we find the chlorine. All right, now this last one, this one may have been the trickiest of the bunch, right? So the main chain is going to be this chunk right here. It's not what is going directly across. You can get more carbons from what I just highlighted there. Now, when we do this, we should really be starting at the bottom, and we're going to work our way to the left, all right? Because that's what's going to give the lowest number of substituents here if you were to count it. And if you don't believe me, you can try it out different ways and try to figure it out. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I tried to give you some different examples here where you can see that we're not just always doing a straight chain count. This one's going from bottom to left. And I gave you some examples where the numbers are switched. So the 4 was coming before the 3 with the ethyl and the methyl in terms of the naming. Okay, and the same thing here. You're going to have a 5 and a 3. So I'm trying to give you a couple examples to implement all of the different rules we've been discussing here. 1, 2, 3 methyl, 4, 5 ethyl, and it's a nonane. So 5 ethyl, 3 methyl, nonane. All right. Here is the structure that we were working with in the Rule 1 lecture. So we were trying to find the longest chain there. So what I want us to do at this point is to go through this one and attempt to solve it. So again, I would encourage you to pause the video for a minute and try to work through this. The name isn't actually up here. Now you may have a head start if you were paying attention during lecture 1, but see if you can solve this, and then we'll walk through it together in just a second. So give it a shot. Pause the video and unpause it when you're ready for the walkthrough. Okay, so this one might take an extra minute for us to go through, but this is a very good example because this is the type of thing you might be faced with on a quiz or a test that you need to work through. So the longest carbon chain right here would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, this could be a bit tricky because there will be people that when they see this, they would be tempted to do the left to right, where they're going to go, oh, I see that we start here, and they'll realize this methyl is not where they want to end, so they'll come up here and try to collect this as the main chain that I just highlighted in blue. The problem with that, if you count, is that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can get up to 11. So classifying this as a decane would not be appropriate. This is going to be an undecane or a undecane. So we would not utilize that as the main parent chain that we just had in blue. We're going to utilize what we have here. Now the next question is the numbering system we have right here, is it correct? Okay. So let's go back and number the other way just for comparison's sake. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So let's look at where these substituents would fall. In the case of the blue numbering, I would have a 5 for the methyl group, and I would have an 8 for the ethyl group. So this already should start to be clear, but just for the sake of making sure everybody understands where we're coming from, the other reverse method has a 4 for the ethyl, right, and a 7 for the methyl. So which do I pick here? I pick the lower set of numbers always when I'm naming. All right. Now, if this had been a situation where we went forwards and backwards and they were the same, like we had seen above for certain examples, okay, in that case, then you would have the ethyl being prioritized in terms of the number if it was the same numbering. So let's say that it was 5 and 8, both forwards and backwards, then the ethyl gets the 5 at that point, okay? So now we're getting ready to name this compound since we have this all outlined. We know that we're going to have an undecane, right? So let's just write that down. Decane. So we don't want to forget that. And we have an ethyl and a methyl with a 4 and a 7. So in this case, the numbers will ascend because it's going to be for ethyl. Again, the reason that that's there is because ethyl begins with E. And then we're going to have dash 7 methyl. Right? And then remember, if there's not another number, there's no need for additional dashes or spaces. So it's 4 ethyl, 7 methyl, and then continuing the name right there, undecane would be the name of the compound that we have here. So hopefully that was straightforward enough. Everybody was able to follow it, implementing the rules that we have learned at this point. Please feel free to reach out if you have any questions at this point in the lecture series. Otherwise, I will see everybody for the next lecture where we will get ready to start discussing some of the common branch side chains that have special naming.